So the context of this talk is, of course, the CLOS project, which I will talk more about in tomorrow's keynote speech. So I won't go through this right now. There's a part of CLOS that's called Cleaver. It's a compiler framework. And this paper is about the protocol that's used for compile time environments in the Cleaver compiler. So the first pass of the compiler translates what we call CST, a concrete syntax tree, which is basically just an S expression wrapped into standard objects. It translates that to an abstract syntax tree. And that phase is basically the same as the minimal compilation that's required by the Common Lisp standard. And so this translation is, of course, a special case of a code walker. And for that, it needs what we call a lexical compilation environment. I don't say just compilation environment because that term is used for a global environment in the Common Lisp standard. And I don't just say lexical environment because it could be the environment of a closure at runtime. So I say lexical compilation. The lexical compilation environment, of course, reflects the nested structure of the code, and it contains all this information based on what kind of forms are introduced during the compilation. These environment objects are passed as the second argument to all the macro expanders in Common Lisp, except that the Common Lisp standard doesn't mention any accessors for this kind of environment object. It's a completely obscure object. However, the book, Common Lisp the Language, second edition, has an entire section, 8.3 or something like that, about lexical environments. And so I guess they were supposed to make it into the standard, but then didn't. And this paper is partly about that protocol in the Common Lisp, the language book, how inadequate it is, and a suggested replacement for it. So if we look a little bit at that protocol, there are functions like query functions for the environment. So there is this variable information where you give it a symbol and an optional environment. Always in these functions, if you pass nil as the value of the environment argument, that means the null lexical environment, which basically means the global environment. So if it's file compilation semantics, it's the global compilation environment. So you pass it a symbol, which is the name of the variable, and an environment object. And it returns 3 values. The type of the binding, if it's a lexical variable, if it's a special variable, if it's a symbol macro, or constant, or nil. Nil means there's no binding for that variable in the current environment, in the environment that was passed. Second return value is a Boolean that says whether the binding is local. If it's true, it's local. If it's false, it's global. And an association list of declarations that apply to that binding. For instance, could be the type of the variable. It could be, what could it be other than the type? I can't think of anything other than the type. Dynamic extent, yeah, that's a good example. Thank you. Oops. Function information is another similar function. You pass it a function name and an environment object again, and it returns whether it's a function, a macro in a special form. Nowadays, we call it a special operator, but this book was written before the terminology was standardized. And again, a Boolean that indicates whether it's local or not, and an association list. Declaration information is another query function. It returns declarations that are not associated with any binding, typically optimized declarations or declarations. And then there's a function augment environment that you can use to create a new environment, which is a delta from the one that you pass in as an argument. And this function takes a lot of keyword arguments so that you can augment the environment simultaneously with by a variable, a function, and so forth. And there are two more functions in there that we hadn't planned to include in the paper because they didn't seem relevant. But then the referees came back and said, why are you not talking about those functions? And at first we thought it wasn't relevant, and then we realized that in fact it is relevant, and I'll get back to that a little bit later. So parse macro is a function that takes basically a macro definition and it returns a lambda expression that has the shape of the lambda expression of a macro expander. That is, it has a form and an environment object as an argument. Hello. And this, the previous function, parse macro, doesn't really belong in that chapter because it's just a parser. It doesn't use any environment as far as I can tell. And in fact, implementation of SBCL and CCL of that function declare the environment ignore. So I don't see how it can serve any purpose. The real killer is this one, enclose. It takes the lambda expression or a lambda expression that could have been returned from parse macro, and it returns a function that that closes over the environment object. So that, and it's used for local macros, like macrolet. So that the environment in which the macrolet is compiled is available to the macro expander, but nothing else essentially. Okay, so the reason we didn't think that that was relevant was that the purpose of this work was to introduce an alternative protocol to the CLTL2 protocol. And as usual, the naive idea was we wish everybody who implements Common Lisp would convert to this new protocol instead. And the referees correctly pointed out that, no, that's not going to happen. And they instead positioned this work as being a portable code walker. And if that's the case, they need this function here. So the CLTL2 protocol is incomplete. It has no information about blocks and tags. It's also impossible to extend because of the way it returns information as multiple values. You cannot add new multiple values in a compatible way. That's just not allowed by the standard. So this protocol is basically incomplete and impossible to extend in any meaningful way. So we investigated several existing implementations, and in fact, no implementation uses this as its native protocol, barring perhaps Allegro, because we don't know the information about Allegro. What we do know is that they added all the missing information to this protocol so that it would actually be possible to use as the native protocol. So our solution is implemented as a library called Truckler for no particular reason. The query functions, instead of returning multiple values, return instances of standard classes. And then we have access or functions on those instances. And that's immediately extensible because client code can return a subclass of, or an instance of a subclass of the ordinary class. And it can have additional accessors to it. So we don't have the restrictions that the CLTL2 protocol does. And of course, it has functions for tags and blocks. So the query functions are these. I'm going to give you one example of a query function and one example of how they're used. But describe variable, describe function, describe block, describe tag, describe optimize, describe declarations. So for instance, a describe function takes a client parameter. We've started using that technique. The first parameter is always a client object. And Truckload doesn't specialize to that parameter. But client code is supposed to pass in a standard object that represents the environment. And that allows us to do several things. We can have multiple clients in the same image, for instance, which is extremely valuable for bootstrapping purposes when you have a host implementation and a target implementation in the same image. Second parameter is the environment object. And of course, the name of the function. So what it returns is an instance of one of these classes. It could be an instance of a global function description, which is a subclass of function description. So client code can specialize to the most specialized class, or to something more general if it's a simple code walker. It can even specialize to generic function if the client code is interested in particular information about generic functions. So here are the accessors for such an object. You can get the name, the type, inline. Inline data is something that the CLTL2 protocol doesn't account for. Any compiler that wants to inline code must also have enough information that it can actually produce the code in line, and client code can put it right there. The other ones, of course, compiler macro, I believe, is not part of CLTL2 either. So here's an example of how to use one of the functions. This is a local macro description, which is simpler than the function description. As you can see, we have here in Cleaver a compile CST, or convert CST, sorry. It specializes to this local macro description. What it does, it finds the expander in the standard object that was returned. It expands the form, and then it does some trickery to recreate the concrete syntax tree from the macro expansion. And it preserves source code information, and then finally it calls convert with expanded CST. So this is a typical usage of one of these functions in the Cleaver compiler. I'm not going to go into the details of the augmentation functions, but this is selection, and of course client code can add more of them if they want to augment the information with different things. Environments can be annotated. That is, you can have locally declare something, and within the scope of that locally declaration, locally form, you can have an environment that is annotated with different types or different other aspects of the bindings. So an example of a customization that we could imagine is, for instance, client code can define a subclass of generic function information, such that it mentions the class name of the generic function, the name of the class of the generic function, and the name of the class of the methods of the generic function. And this is precisely what we suggested in our paper on make method lambda a year or two ago, I forget. Another possibility is you can imagine, for instance, an implementation that has purely global variables like SBCL does. They could have a subclass called global variable description, that contains exactly the information for that kind of global variable. And this would be done in a backward compatible way. So the advantages is that it's easier to customize. The fact that we have this hierarchy of classes means that if you have a simple code walker, it can specialize to only the very least specialized classes and still function, whereas a sophisticated compiler can use specialization to the very special classes. And like I said, code for different clients can exist in the same image. Disadvantage, more consing, of course, more allocation of new environments. The thing is, I don't think that most code walkers would actually have a problem with more consing, because if you take a compiler, almost all the time in a compiler is spent on optimization, so it's not the conversion of a CST to an AST that takes time. And of course, if your common Lisp implementation is bad with generic dispatch, then all our functions are generic, so it might take a little bit longer, but then they should probably improve their generic dispatch. Future work. Currently, Trucklers has code for, well, Marco can say more, I guess, for SBCL and CCL, right? Yeah, and we probably did not include CLOS in Truckler. Or did you? No.
At least I don't recall doing so.
Right. And Cleaver doesn't need it because Cleaver has its own obvious implementation of the equivalent. So, but it would be good to supply it if we want to follow the advice of the referees to say that this could become a code walking library. We want to improve documentation with respect to customization. And of course, yeah, we want to provide parse macro and CLOS for more implementations, including the ones that we forgot about. Thank you very much.
This was a CLOS implementation.
I'm sorry?
This was a CLOS implementation.
Yes.
Given your comments on generic dispatch, what were the wins that you had by implementing it in CLOS over any other approach?
Oh, that has already been.
Please repeat the question.
Okay. So if I understand your question correctly, you want to know what one should do if one were to re-implement CLOS with faster generic dispatch?
No, quite the opposite. Quite the opposite. What were the wins that you had in using CLOS for this application?
Oh, the customization, obviously. The possibility of overriding and extending methods on the existing generic functions. The possibility of defining subclasses of the classes that the library defines for specific clients. Yeah, all the customizability of CLOS, if you want, yeah.
I've seen you proposed to be able to access also to data inline or inline data related to functions that are inlined by the compiler. Are you suggesting also the format that should be returned, or this is just up to the compiler?
The format of what?
Of the data that is returned.
Please repeat the question.
Okay, so the question is, we suggest that inline data is returned, but have we also suggested what form that inline data takes?
Exactly.
No, the client code is free to put whatever he wants in there when a function is defined to be, and it's declared to be inlined, and the same client must then access that information when a call to an inline function is found.
For a client, you mean the underneath compiler, the implementation?
Well, if it's not a compiler, then the inline information probably isn't interesting anyway. So.
Okay. Okay, I understand. Thanks.
Yeah, I'm sorry. I keep thinking of compilers.
Any more questions? Zoom? Yeah.
No, I had there weren't any questions on Zoom that I saw. Robert, are you familiar with how LLVM or GCC handles the environment and symbol lookup?
No, I'm not.
I'm not intimately familiar with that, but
No.
they spend a huge amount of time optimizing how fast you find a symbol in the symbol table. And
Okay.
It's surprising to me that they think that that's the most important thing, that you minimize the number of walks up the tree to try to find the location of a variable. Did you?
It's very surprising to me too, because I cannot imagine how any compiler that uses LLVM or GCC would spend any significant time in our environment lookup.
Okay.
I'm not that familiar with the environment functions, but is there something to also, given an environment, list all the available variables, functions, etc.?
Not in the CLTL2. Yeah. Okay. Are there functions also to list all the available variables and all the available functions and so forth? Not in the CLTL2 protocol, but as you can see in the paper, Listworks actually did that. They have a map environment function or map variables or something. I forget what it's called now. You can see it in the paper. That actually maps over all the possible variables or all the possible function names in an environment. So then you can just collect them in a function that you pass to the mapping function. None of the other implementations did that as far as we could tell. Only Listworks.
And, by the way, is it possible, for instance, to map only the local definitions instead of the whole environment?
Is it possible to map only one?
The local definitions, for instance, the local variables instead of the whole environment, going up to the global environment.
As I recall in Listworks, what you need to do is you have to filter that yourself afterwards, figure out whether it's local or whatever.
Not particularly efficient, then it's a bit heavy.
Yeah. Also, they omitted a certain number of things. For instance, the function names that you give cannot be of the type setf symbol, and they forgot about a certain number of things. And I had an email exchange with what's his name again? Martin about that. Yeah.
There's a question from online.
We have a question from the online participant. It is there a scope for supporting user-defined declarations?
I do not remember now whether we put that in explicitly or we just count on, well, all the user-defined declarations are, according to the standard, are proclamations. Okay, you cannot have local declarations. You cannot define new local declarations. It's not possible. They all have to be proclamations. And so the declaration information function will return the ones that are available then. That's it.
I assume it's okay because it's not my question.
Okay, thank you very much.